what a system is. So the first question is, what is a system? What is a system? What is a system? So a system is a specific portion of matter. In scientific research, a system is a specific portion of matter. Is a specific portion of matter in a given region, in a given region, in a given region of space, that has been selected, for study. That has been selected for study during an experiment or observation. During an experiment or observation. Or observation. So if we take an example, for example, if we say that when we observe a reaction in a test tube, for example, when we observe a reaction, in a test tube, the test tube and its contents form a system. The test tube and its contents form a system. Form a system. So basically, a system is a specific portion of matter in a given region. So in this case, the matter we will be talking about here in the example given is the test tube and its content being a system in that instant time in a research. The next idea that we are going to look at is that hypotheses are testable statements. Hypotheses are testable statements. Hypotheses are testable statements. So if you have a statement which you cannot test, then that statement ceases to be a hypothesis. If you have a statement that cannot be tested, then it ceases to be a hypothesis. In hypothesis, it has to be testable. So as scientists examine and compare the data from their experiments, they attempt to find relationships and patterns in their words. So as scientists examine and compare the data and compare the data from their experiments they attempt to find relationships and patterns, In other words, they make generalizations based on the data. In other words, they make generalization. Based on the data. So generalizations are statements that apply to a range of informations. So to make generalization, data are sometimes organized in tables and analyzed using statistics or other mathematical techniques, often which then with the aid of the graphs or computers, people can be able to make clear analysis. So to make generalization, data have to be are sometimes to make generalization. Data are sometimes organized in tables. And analyzed in tables and analyzed using statistics or other mathematical techniques or other mathematical techniques often with the aid of graphs and a computer. So after gathering data, what scientists do, they take this data and they construct graphs. So from these graphs, they can make generalizations. So scientists use generalization about the data to form hypotheses or testable statements. So scientists use these use generalization generalizations about the data to form a hypothesis. To form a hypothesis. So hypotheses are not just statements that are formed without basis. So you have first of all to collect, to carry out research from previous information, and from previous information you collect data. After collecting your data and observing, then you'll make a hypothesis, which is normally a testable statement. So the hypothesis serves as a basis for making predictions and for carrying out further experiments. So the hypothesis will serve as a basis for making prediction. The hypothesis serves as the hypothesis serves as a basis for making predictions. After making these predictions, of course, you have to carry out further experiment to prove if your predictions are correct or wrong. So hypotheses are often drafted as if-then statements. So the then part of the hypothesis is prediction. That is the basis for testing by experiment. So let's look at figure. So let's look at figure 1.2. Let's look at figure 1.2 as an example here. So hypotheses are testable statements. We are saying that hypotheses have to be testable statements. If we cannot test these statements, then we are doing nothing, and we are not carrying out any investigation in that case. So what we will do here, let's go through this sample here and see. Formulating hypothesis. So a graph of data can show relationship between variables. In this case, the graph shows data collected during an experiment to determine the effect of phosphorus fertilizer, to determine the effect of phosphorus fertilizer compounds in plant growth. So here we have growth as in health or height, and here we are having time of the day. So you can see when they use 50% fertilizer that the graph, it produces the highest growth. When they are using around 25, it is almost the same, and as it drops, so it means from here, from this graph, you can make predictions that what happens that after 25, even if you add more of this fertilizer, it will have no effect. But from no fertilizer to 10, you can see that there is growth, and there is growth also as you add more of the fertilizer until you reach around 25%. So from this analysis, we can now make predictions about phosphorus, or a statement of hypothesis. So how will you finish this hypothesis? If phosphorus stimulates corn plants growth, then if phosphorus stimulates, if phosphorus, for example, stimulates corn plant growth, then it should be the increase of fertilizer leads to an increase of growth. So you can test this if you are able to test it and you come up with the right thing. This maybe has not happened yet. So you will go down and make an experiment and try to find out if these things really can happen. So in this figure, the data, you have seen in this figure that the data that you collect, you can use them to make an analysis, then come up with a hypothesis. So scientific method, to be precise, is continuous and does not stop and will progress from any angle. Let's look at this here. So, as we see, scientific method is a set of procedures that scientists follow, and this set of procedures is what I want you to be able to see. These sets of procedures are what I want you to see clear here. So these are just, for example, here we have observation. Here we are having identifying a problem. After identifying a problem, you gather data. After gathering data, you make a hypothesis. After making a hypothesis, you test the hypothesis in an experiment. Does the new data agree with the previous data? So first, ask yourself a question. Do a background research. So you have, this is where we start. This is where we start. We start by asking questions. After the questions, we go to background research. After that, we construct hypotheses. We test these hypotheses, analyze the data, and draw conclusions. So you can report these to your peers. And the fact that a scientific method is always going round, it can start from anywhere. We can start here again, for example. Communicate to your peers. Ask questions. Perform background research. Create hypotheses. Draw conclusion and analyze. So it goes round and round. But there is no specific place where it starts. It can start from anywhere depending on the kind of research that we are carrying. So the first thing we do, we ask ourselves only the question. After questioning, we go to step. We have only 6 steps here that are categorized. So we question ourselves. Scientific proposes the problem. 2, so this is questioning. 2, you make a hypothesis, a potential answer to the question that you had. After making hypothesis, then you carry out an experiment to find out if it's true. So other investigations that are intended to prove this true or false. So you carry out an experiment here. After your experiment, observation, a statement of non-knowledge gained through the senses. So you can see question, hypothesis, experiment. Then you have observation. From this, you could go again, or you could progress and make analysis, comparing the results. And 6, after analyzing, you draw conclusions. And a conclusion is a statement that gives whether the original hypothesis was supported or refuted. So here, questioning, hypothesis, experiment. But you could start, it could reach here and go back for another hypothesis, or you could have a hypothesis and ask yourself another question, or you could have drawn conclusion and go back and make observations, depending on how the results of your outcome was. So question can start here again. So we are saying that there is no specific timeline that we will follow. We will take an example here. Here, I have come home, I try to put on my computer, I cannot get the internet signal, so I will start observing. I will go to the computer, I will check the cable if it is connected. That is a question. Maybe the cable is not connected. Maybe the cable is not connected. I will check the cable. Maybe the cable is connected. I can make a hypothesis, then carry out an experiment, then draw observation, that is observing here. Then after that I can analyze my data and draw conclusion that my computer has no problem, for example, and the problem is with the internet supplier. So if I have carried out all these, maybe the problem was with the router, or the problem is with the modem, or the problem is with the computer. So this is what we are calling, so we'll ask yourself, if this one is carried out and it is ticked by experimentation, we can prove that the router is fine. So this observation can start from any place here. It could start from looking at the cable here, or at the router, and so forth. So that is what we mean by scientific investigations. Scientific investigations. So we will proceed. So we'll stop here, and in the next video we will be looking at controls and variables.